Okay guys, welcome back to the channel. Yeah, so today we're going to be talking about actually illustrating the Siempinski Triangle with OpenGL and Blender. So yeah, the Siempinski Triangle is this it's an interesting triangle that is normally made by making some recursive calls to a function that helps us split a triangle, a main triangle, into many other small triangles which are inside the original triangle. Yeah, so normally if you are to make the triangle by hand, the procedure is normally simple. You just start with a large triangle, you divide this large triangle into 4 new triangles by connecting the midpoint of each side. Ignore the middle triangle that you just created, then apply the same procedure to each of the other 3 corner triangles. Each time you create a new set of triangles, you recursively apply this procedure to the 3 small corner triangles. Yeah, so basically I think it would be better if I just showed you how it's supposed to look like. So let me just run this piece of code right here. It's called the Siempinski OpenGL. Yeah, so basically this is what it's supposed to look like. You basically have a main triangle with other smaller triangles inside it. Yeah, so let me get to explaining the code. So first things first, we have our models that we import over here. As I said, I'm actually using a Pygame and OpenGL. Yeah, so I think first things first, you have to initialize the glute, which is done right here in the first line. Yeah, then you have to create our functions to actually create this triangle. So first you have to just define a basic draw triangle function that takes points and actually assigns a color to those points. You can see that that over here I was just taking or just beginning or using the model called GL triangles in OpenGL, and yeah, and actually assigning the color over here to actually the color which will be input in the function over here. And over here I'll just basically stating the vertices of the triangle, because a triangle has 3 vertices. So what we're going to do is we're just going to actually draw the triangle with, yeah. So we got the next function. It's called the get mid function. So as I said before, we actually take a larger triangle and we actually use we actually try to get the midpoint of each of this triangle and actually try to create triangles out of this midpoint. So the get mid function over here actually takes 2 points. We can call it P1 and P2, where they'll actually contain the x and y coordinates. Since we're doing this in 2D, it actually contains the x and y coordinates for the triangle. Yeah, so basically what we do is we take the first parameter, which is basically this will come as list. So we take the first x coordinate and the second x coordinate of and then we divide by 2, and then we take the first y coordinate and the second y coordinate and divide by 2. Then we return the actual midpoint of the points are given in the first in the parameters over here. Yeah, so let's define the function as Siempinski, which is actually going to draw these triangles. Not even draw, basically define how this triangle will be drawn. So basically, since we're supposed to draw the triangle with different colors, as you've seen the output, we basically make a list over here that are going to call the color map, that is actually going to be mapped to each of the triangles that are drawn, just for it to have some sort of diversity in the colors. Yeah, so right here we call our draw triangle function, which are defined over here at the beginning of the code, which just takes the points and the color. Yeah, and that will draw the function. So basically what we do is we actually recursively call this function until the degree is actually 0. Yeah, so basically it's basically that this is actually the main code, but what we're going to do is, if the degree is greater than 1, we're basically going to be decreasing the degree minus 1 until we actually get to 0, where we'll have a full triangle with the triangle inside it. Yeah, so normally we just take a point over here. As you can see, the Siempinski function takes points in a degree, so it will actually take a point. It will actually take some points and actually the color map degree, which is basically what we're trying to do is we're trying to map out different colors for each recursive level that we reach. Yeah, then we just basically this is just some code to just draw the Cartesian plane that you'd seen, and actually creating the axes, the x and y axis, from negative 150 to 150 on the other side. But I think it was actually a negative 300. Yeah, on the x and y axes. Yeah, and then we initialize the OpenGL settings over here. This render text function is just to basically draw our characters, those characters that you had seen in the OpenGL window. This not even characters, what do you call it? These are numbers like the 150, the 100. Yeah, basically that's the function to actually render the text to the actual display. Then we have our main display function, where we actually just use the GL clear color buffer bit function, rather the OpenGL setting. Then we call the draw Cartesian plane function, which is supposed to draw the Cartesian plane with the x and y coordinates are mapped. Yeah, and then now what we do is I create a triangle with the initial coordinates, which is negative 100, negative 50, 0 to 100, and 100 and negative 50. Yeah, so what we do is I map this to the Siempinski function, which you can remember takes actually points and a degree. So it will take these points and then we set our degree, or rather depth, to 2. Yeah, so basically this function will run until the degree becomes 0. Yeah, so then we have our main function. This is just to basically name the OpenGL, the Pygame window. Yeah, and then we initialize this function right here, the OpenGL settings, which is over here, which are created right there. Yeah, and then this is just a basic code to just quit the window in Pygame. Yeah, and then we call our main function. So just to run this code again, yeah, that's how it's looking like. We have our main function. So basically, if you think about it, like the first what do you call it? The first triangle that created was blue, and the second one was actually given a different color. So basically, we're having different colors for different degrees. So basically, this is the second when the degree was maybe 1, and then this was the last triangles to be drawn, the ones in red. That's why yeah, they have different colors. Yeah, so so let's try and actually try to clip the main those small triangles inside it to remain with the actual what do you call it, to remain with the OpenGL first triangle. So yeah, we have that right here. I'm not sure if you can run this. Sorry about that. I think I've mistaken something right here. Yeah, I think they should run now. Yeah, so if I run that, you can see that we have original square with all the inner triangles removed. So let's see how we got to that. So basically we just took this code from before the triangle function is the same, but actually right now we're actually using the shapely geometry of function right here. This is just to try and use the what do we call it, the line clipping algorithm. I think it's called a greiner-Hormann or something. Yeah. So that's how we use it in Python. Normally if you're using C++, I would imagine that it's called a different way, but for Python we can use this library to actually use that algorithm, the greiner-Hormann algorithm. Yeah, so the getMid function is the same, the Siempinski function is the same. So now we have a new function called the clip polygon. Well, basically we take a subject polygon, which is basically like the I think like the as how can I explain this, like the over, like a window sort of polygon, and actually have a clip polygon where we expect our original polygon to look like, and then we basically assign this to the polygon what do you call it, a geometry type. Yeah, and then yeah, we basically try to make an intersection of the two, and we actually return the clip result. Yeah, so basically this is an attempt at actually trying to clip the polygon. Yeah, the Cartesian initialize and the display functions are just the same as the previous. So basically what we do right here in the display function is actually we have my points, which the original coordinates that I put in the first function right here. And then what we're trying to do is we're trying to intersect it with an outer rectangle, where this rectangle, when intersected with my points, will actually result in the original triangle being drawn. Yeah, so what we do, yeah, after that we just draw the clipped result in a blue, just for that to have a blue color. Yeah, so if I run that again, it actually looks like that. Right here, this was just like an attempt at trying to line clip, because normally when I line clipping, we normally try to line clip. For example, in this case, if you were to line clip using the inner triangle, like over here in this case, in the green triangle, if you were to line clip, it would just be basically trying to remove everything that is outside the borders of this triangles. Basically, it would remain there with the green function, with the greener triangle. But this becomes tricky one when you actually have our main triangle, which is a blue one, and we're trying to get rid of the green and red triangles, which can be sort of a challenge. Yeah, so in my case, I was just using some arbitrary rectangle and trying to intersect it with the original triangle, and yeah, this is the output. So I think now we can try and create the code, this same code in our Blender. Yeah, so basically we can try and draw the Siempinski triangle in a Blender. Let me just switch to the Blender tab. Yeah, right here, here's the Blender functionality. As you can see, it's already running over here. So yeah, this is how it looks like. We actually have a triangle, a Siempinski triangle with different colors. Yeah, so let me just explain how this code works. So first we import the Blender Python module. Then we use this same shapely geometry library to try and to import the polygon functionality and the multi-polygon functionality. So first things first, we have to create a function to define the clear existing objects, which is basically we just use the bpy.ops.object.select all. We select that action to deselect. Basically, what we're trying to do is just to create just to clear all objects in the whole windows. Basically, as you can see, like in this window, there are no other what do you call it? There are no other functions or other objects in this window. So we only have one, which is this triangle right here. So next we have to make a function called create material, which actually returns a new material with a specified name. Yeah, so basically over here I will just assign sort of the colors, the material, and the color for this function, for this triangle. Well, we basically take, it's a function that takes the name and the color and actually assigns it to the actual object. Yeah, so next you have to define a function that creates a mesh object with a specified name, vertices, and material. So it takes the mesh name, the object name, the vertices, and the material, and it tries to map that to the object. Yeah, so over here we're just trying to achieve that, where we actually store the mesh variable, the obj variable, and the obj.location variable to this bpy.context scene cursor location. And yeah, over here we're just trying to append the list that you create. Yeah, so for the next function that we do is it's called the clip polygon functionality, where I'm actually trying to clip this polygon, but this I actually couldn't achieve this yet, which so basically this is just boilerplate code where I was trying to clip this triangle, but not yet. It hasn't been clipped yet. Yeah, so this code right here was still non-functional. Yeah, so now we have our draw Siempinski function, where we take these points, the first point, the second point, and the third point. These are just the vertices of the triangle with the actual depth or the degree, like in the previous example, and the colors that we map to the object. Yeah, so what this function does, we just recursively draw the Siempinski triangle with the specified depth. So basically, if the depth is greater than 0, we just run this function recursively until we actually I'm not sure if you can see this. Let me just edit the so that you can actually see what this code is saying. Yeah, right here. So as you can see, we actually draw this. We actually call this function right here, where we actually reduce the depth -1. Basically, after drawing the triangle, just reduce the depth. It's the same as the previous scenario, where we're actually mapping the we're actually mapping the triangles. So actually trying to create the triangles recursively, but also while decreasing the depth by -1 after it's actually called. Yeah, so yeah, this just for the first if statement. We actually have a global variable called num over here, which will actually help us in the main function. Yeah, so num is actually increased by 1. This is just for the for loop that we're basically trying to track how the depth that decreases, or how many times the loop has run. Yeah, else we just create a material for the triangle, and we create the mesh and object for the triangle using the functions which we had defined over here. The create mesh object and the create material functions. Yeah, so then we have our main function to draw and clip the Siempinski triangle, where we call the clear existing objects function, which clears all objects in this scene. We have our global, which we call again, and we initialize it over here. Then we define the initial vertices of the base triangle, which is -1, -1, 0. As you can see in this case, okay, Blender is normally used for 3D illustrations, but in this case we're trying to draw it in 2D, so that's why this vertices over here are actually 0. This actually, I think we can call it the z-axis, sort of, yeah. So the x and y is the only thing we're assigning in this case. So we have -1, -1, 1, -1, and 0, 1 as the vertices. But in Blender, we have to define it as using the x, y, and z coordinate, unlike OpenGL. So then we define initial depth of the recursion, which is 2, which is same as the previous example, and we define colors that will be mapped to the triangles that are formed recursively. Yeah, then we just start drawing the Siempinski triangle over here. So we just assign these vertices that were given in this list over here to the function draw Siempinski, which is defined up there, over here. Sorry, over here. So it actually takes in these parameters and depth and colors. Yeah, so over here we're just calling it, well, I actually call it I just call the function over here with the vertices that we need, which is x1 and y1, x2 and y2. It's just that we're calling. Yeah, then we define the vertices for the original triangle. This is over here just trying to sort of trying to do the line clipping, but yeah, still wasn't successful with that. But we define the vertices for the original triangle, which is equals to the vertices that is defined up here. Yeah, over here I was actually trying to do the line clipping again, but it wasn't too successful. So this block of code is also not that functional. Yeah, so yeah, that's it for today. Basically, this is how it looks right now. If you were to achieve line clipping, actually this inner triangles would actually disappear. I think we could use back clipping, but I still hadn't achieved that as of right now. But yeah, so yeah, that's basically it for today. Yeah, that was actually the demonstration of the Siempinski triangle in OpenGL, and actually trying to clip it using the greiner-Hormann algorithm, which I was actually trying to define over here. I was actually trying to sort of use in these scenarios, but I was not successful. Yeah, so that's it for today, guys. I'll see you later.